Coming to the half-cell potential measurement, what is the purpose? I want to analyze the surface of the concrete, not the surface. I want to analyze the potential field of corrosion in the concrete, that I can use this machine to do the tests, that I don't have to do the whole surface. To detect areas, it is easier to find, like I said before, corrosion caused by chlorides, because it's a bigger surface and it's more difficult to find the holes, corrosion, what is just like a hole. The area of use is, one more time, just the detection and the survey for the dispersion of corrosion in a concrete building, and the pre-assessment before destructive testing, like the machine. I'm not too sure, maybe Mr. Tarayan knows quite good some information sheets. I use those because I know they are I know them very well, and I know they are very informative. These two, DGZFB is the German Committee of Non-Destructive Testing, is doing technical consultancy, is doing the norms, and also institution work. Same for SIA, this is in Switzerland. If you want to get more information, I think it's the best to ask Mr. Tarayan. My information is only those two sheets are very well, cost about 100 Swiss franc. Maybe if one is going more into detail with projects, I would buy them, translate to Farsi with a translator, and then I have a very good information. This I have seen on the ASTM norm. You can see here how it works. The principle, you have the reference electrode. Over here, you have linked one electrical wire to the rebar. I got yesterday the question, when here it is linked, and maybe I don't have electrical flow up to there. Usually the rebars are 6 meters. Also in Iran, 6 to 8 meters. So I know if it is linked here, at least I have 6 meters. If it is in X and in Y direction, 6 meter, I know it is linked also, and then the rest is done with the wire. Here you can see, like we were talking about microvolt, when it is nice, you get a normal signal, you get this yellow, and the darker it is getting, it's all one more time color. You have a deeper minus in microvolt. This is how it looks like. You have seen before. You fix it. I usually I have more or less 5 years experience with concrete from my time as a technical drafter in a civil engineer office. And later on I did the engineer for mechatronics. So I also have quite a good experience with electric. I prefer to drill a hole with a 6mm driller into the rebar because I know the connection will be nice. You can also use a clamp and fix it, but then maybe you lose it. So the contact best is done with drilling a hole. Then you see it is linked, and you can see as long as this rebar is going on, you will have some connection, and then you get the fields. And here, like here, when you see the corrosion, you will get different results. What is good when you have this software, not our software, this is from the norm, you can use these charts also on Excel sheet, and then you get this type. What again? Sorry? Conical. Thank you. When you get this conical, you know here I'm fine, here. And the deeper I get, the more potential of corrosion I have. So I know I will do the chipping here. I will show you on the screen how you can do this. Instruments for the testing is voltmeter, like we heard, is the cheapest and simplest way to start for the cross-check first and for small surfaces. Then we have Canin, and now the new version is Profometer corrosion, what is cover meter, and with this adapter also for corrosion. On the reference electrodes, you can use one electrode. What we have seen, the rod electrode, we can also use one wheel, so to become fast. And if you have big areas like bridge, car parks, you can use 4-wheel. You will see later a few pictures how it looks like. And then usually when you start, one cable roll is 25 meter. I would say you start, when you have a bridge, take 3 cable rolls with you, you have 75 meter, and then you can work nicely. How to get the project started? It's not written. I would say read these information sheets you can get. First, that you have a good overview, then organize the positions and fix the cable with the rebar. First check you can do with the voltmeter. And then you clean up the surface, you water the surface, and you fix the grid for the measurement, like 25 centimeter by 25 centimeter. These are the, like I said, voltmeter. It's cheap to buy, easy to use, and a very good start for the first cross check, especially when you do the first check, you see the cover is dropped down and you can see the rebars. I can do a cross check over there. The old version with interface is Canin. The new one is the cover meter, Profometer corrosion, like I said. And the rod electrode is like Mr. Darayan already explained. I'm not too sure, that's why I explain shortly. You take the copper sulfate in, you saturate the water, and when the water is saturated, you give 1 extra teaspoon in that it is still with mineral inside. So this usually, Canin is usually the instrument where we find the most Daniel Düsentrieb as end users. They prepare themselves with the extra tools. It's like one rod fixed on 8 to do the slabs. On a bridge, you will be faster. And the good thing is the moisture of the foam will be on this side nicer and easier than with the wheel. This picture is done from the University Rapperswil in Switzerland. These professors use this to do the test on the bridge. This instrument is already a bit more sophisticated with 4-wheel for big bridges and for car parks. Why? This is the chart that you have seen at the beginning is from Mr. Dauberschmidt, and this is the company of him, and he's also on lecturer on the University Munich. And you know Bavarians are good in brewing beer, and this is like the beer trolley when you have this to bring to the restaurants, and they created this, then they have the platform. You can see here this the Canin, and here's the Profometer. So they do one way. I have a project, or I have an end user who is doing a project in Vienna this year, 80,000 square meters. So if you have to run twice, it's 160,000 meters. This instrument you can do in 80,000 meters. So because they use it together. And this is the idea of the new Profometer corrosion. At the moment you have 2 ways to go. In 1.5 years you will do 1. And the one wheel is good to start. You don't have to start with the 4-wheel if you don't have a really big project. Grid for testing, like we heard before with the whole corrosion. The grid should be taken not too big, that you don't oversee the small little corrosion spaces. So standard is 25 by 25 For bigger projects, start with 50 by 50, but really like the 80,000 square meters. And then you say, okay, this area doesn't look nice, I will do 25 by 25. So for preparation, as you can see here, cleaning the surface is important because then you get better contacts with the probes. You moisture the concrete 20 minutes before. I have one customer in Zurich. He's using Canin frequently. They have 4 instruments with 4 wheels, and they wait when it is raining, and then it is cloudy, it stops raining. Then they do the measurement because they know the moisture of the concrete is everywhere the same. It shouldn't be that you see the water. It should be saturated in the concrete. Then you have fair results and better to interpret. Okay, one more thing. Like in Tehran, you have very warm weather. Avoid strong dehydration during the measurement. If you do it on a sunny day, 32, 35 degrees, it's not good for the results, because dry concrete will lift the result 100, 200 millimeter microvolt. To explain the results, you can use the software, and then you just overlap it on the drawing, and now you have this. What we have seen first is yellow is good. The lighter it is, the lighter the yellow is, the better it is, and the darker it is, the more problem and the more potential for corrosion we have. And this is from the same gentleman in Germany. And then you can see the picture when they chipped it up. When they did the chipping, they have this result. This is out of the German Committee for Entity Testing. Sorry, it's again in German. It's an overview. It's not the Bible. It's just an overview. It should give you the information that you can start. Here, passive without chloride, you have the full area. This is when you have the pores filled with air. You should get these results. If you have this kind of macro corrosion, hole corrosion with the small spots, because of chlorides, you are in this area. And if you have this surface corrosion, like we have seen the picture before, you will have bigger potential difference, so you will be more close to 100. As we said before, calibration on site, this is just the information. Good to know is if you analyze car parks, if you analyze bridges, these all are a must to get a good survey. Like optical check, just go through. Then you can also do your first tests. Concrete cover measurement with the cover meter or with ferroscan from Hilti. Half cell potential checking the chloride value of the concrete and the detection of the rebar structure, and analyzing the depth of carbonation. If you have this all together, you will get a good result, and then you can also say, dear construction owner, this is my result, and this is a fair result. What is optional is using the Recipot for the electrical resistivity and analyzing the mixture of concrete. This is optional. Those are a must. I have said I have 2 pictures. This is in Austria, happened 2008. You have this wall, and then you have like a half slab to reduce the noise from the highways. And then it cracked, and one Bavarian lorry driver died. And then Austria said, the government said, now we won't test all of them, because they found out because of freezing and getting hot, freezing and getting hot, the corrosion was already in. The machine you have seen first is coming because of this accident. This accident happened, 7 firemen died in Switzerland, Solothurn. You can see here the column. And because of the soil, you have a lot of moisture. And then it was not very well designed and calculated, but also because of the moisture, they have had corrosion. So they said after this, all those car parks who are older than 20 years have to be checked. It's a pity, but it happens all the time that first is an accident, and then we wake up and say, we have to do this. Sorry, you had a question? No? Okay. So this is on corrosion side, my presentation. Okay.
Does the promoter have a built-in GPS or something like that? I mean, when you move from one place to another place, does it register the points? I mean,
usually you will do a grid on the floor. GPS is not as nice. Just think about if you have the drawings, you have seen the drawing. You will have nicer reports with the drawings overlapping than with the GPS. With the GPS you have, but then you have a car park, 8 floors. You cannot do the GPS. So it is much nicer to have it that you have DXF files. The DXF files. Let me show you. Because with the GPS you will have every point GPS. But if you look at this, it will be more interesting for you and for the person who is the owner of the building, because you can show them straight on the drawing. This is my result from the car park, this one, okay? You have here the millivolt, you have the colors, and let's say this is the room. This is the car park. So this corner is over there. This corner is over there. Okay, fair? And now, what you can do, it's your experience. This is just an assistant. If you have the GPS, this is which floor? Third floor.
Yeah.
With the GPS, you would have to explain everything. Here, you just take the drawing from the third floor, or you say third floor, and then you have this is a cumulative curve. This is from those data sheets, what I have shown. This is passive, no corrosion, should be no corrosion. That's the neutral, and that's corrosion, active corrosion. Passive, neutral, active. So my experience, I would say here, I make it bigger. This is one interpolar, and here is one. So I press it here. And now I take the chipping graph, and now I can overlap on the drawing and say, gentlemen, I have to chip here, and I chip here as a cross-check. And then if we have done the chip here and here, the person who is the owner can say, this and this has to be done. I think this is easier if you have DXF files to do the overlapping, because worldwide the CAD system, drawing system, computer animated design with DXF file, nice. Big project 1 to 100, smaller one 1 to 50, for sections 1 to 20.
For the picture you showed, with 8 cells at the ceiling.
Bridge.
Bridge, yeah, ceiling of the bridge. From the top. Don't need to.
Give me a second, it's easier. You just say stop. No, done. Which one?
The man have an instrument with 8 electrodes on it.
stop. No.
Yes.
Okay.
Yeah. How does he connected the electrodes? I mean,
He did him by. It's a university. It's the University Rapperswil.
yeah.
They do technical consultancy to get more experience. It's not just lecturing. They want also to do on-site tests. And this was a project of a student to get it done. And we had, you could see this. This is blue. This had 8 channel. Now the new one has only 4 wheels, so we have 4 channel. Now for the new, you can use 4.
Okay, the machine, the sense, does the profiler have the ability to
Have 4 channels because of the 4 wheel.
Yeah. The new one.
And there was previous one with 8 wheel, but it was too heavy.
So any electrodes must be used from one connection. They cannot
Yes.
cannot be serial.
No, you get one result. That's the good thing because you don't get the average.
This 8 one. How about this?
It's also 8 results, but this only with they are blessed or lucky because they have this old system. It was once a project. The Prosek started to have 8 channels, but then no one wanted it because it was too heavy, so they reduced it to 4. 4 wheels, 4 channel. Yes. Because of 4 wheels, 4 channel. So 4 electrical signals. And it's not the average, you get 4. So one rod. 4 signals. For big surfaces. Yeah.
How about the coverage area of one electrode? How this distance can cover?
Usually 15 by 15, and as we have said, no, and this one, the distance.
The coverage of any electrode. How distance then can, or how much?
The electrode will have a line here, and then in between is 15 centimeter minimum and 25 maximum. This is what I have said. 25 is in Europe standard.
لازم نیست روی میلگه باشه چون اصلا ما
نه بحث
نمیدونیم
بحث تاثیر قسمت مفید منطقه‌ای که هر الکترود میتونه جوابگو باشه بین 15 سانتی متر تا 25 سانتی متر.
منطقه مفید نداره. شما وقتی میخواید کار دقیق تر بشه طبیعتاً فاصله رو کمتر میکنه. مثل نقشه برداری شما مثلا وقتی ممکنه 5 متر مثلا یه شبکه درست کنی،
فاصله بین هر الکترود که میتونه کاور کنه
مثل 5 متر شبکه درست کنی، میتونی چی 1 متر شبکه درست کنی. مسلماً اون که 1 متر شبکه درست می‌کنی تعداد اندازه‌گیریات فوق‌العاده چی بیشتره.
بحث این نبود که میزان اندازه برداری اولیه رو چقدر بگیری. بحث اینه که این هر الکترود میتونه بیشتر از ماکسیمم 15 سانتی متر کاور نمیتونه بکنه. یعنی فاصله بین هر دو تا الکترود بیش از 50 سانتی متر نمیتونه باشه. یا مینیممش مثلا 15 سانتی، یعنی بین هر الکترود 30 سانتی متر فاصله است.
من تا اونجا که میدونم بیشتر دقت برداشتمون چیز میشه از نظر خطوط ترازی.
کیفیت اندازه برداری هر الکترود من دارم.
طبیعتاً شما مثلا یه میلگردی یه جا داری نمیتونی بری 2 متر اونورتر.
تو این دستگاهی که ظاهراً با 4 تا کانال کار میکنه فاصله بین هر الکترود نمیتونید مثلا شما 1 متر بعد 4 متر رو با هم نمیتونین کاور کنید. منظورم اینه.
نه اگه شما مثلا فاصله اینا رو بیشتر میکردن مثل این بود که شبکه رو دارن
میکردن
بزرگتر میکنن، دقت کارشون پایین میاد دیگه. بله خب ما در واقع با توجه به تنگی وقت بریم سراغ بحث بعدی. در واقع اون چیزی که الان میخوان توضیح بدن یک دستگاه آرماتوریاب هست.